Hi, in this video we will learn about another notion which is related to derivative of function called rate of change. Well, there are two kinds of rate of change. Let me start with the average, so definition. So we are having a function, so let f be a function on interval AB defined on this. Then we say this is the definition, the average rate of change of f on the interval AB is equal to this value. Just you find f of b minus f of a, end point, starting point, divided by b minus a. That is the formula you need to know for a rate of change. And what is the reason for this naming? Let me just put this in box. What is the reason for this? Well, let me just tell you why we call this. See that in the numerator, which is what? Which is f of b minus f of a. It basically tells us what is the change of f on this interval. It's called net change of f on AB. Now we want to see that this change that happened on the interval AB, what is the rate of that to the change of x. So b minus x, b minus a is the how much x changes, and on that interval f changes that much. So we are basically trying to find net change of f over change of x, basically, yes, on AB. That's why the name comes with rate. And why do we call average? Well, because it doesn't encode all the changes function have. And actually another reason is that we have another definition which says, well, there is another rate of change, which is called instantaneous rate of change. So again, let f be differentiable at a point A, then instantaneous rate of change of f at A is equal. So before it was average rate of change on an interval. Here, instantaneous rate of change at a point. And most of the time you will see me not saying the word instantaneous. If I don't include instantaneous, it means, well, I just say rate of change, it means instantaneous rate of change. Okay, what is this? This is exactly the derivative of that function at A. So the derivative of function at A, remember, is kind of slope, it kind of changes, shows how the tangent line, the rate of change of tangent line is. Now the rate of change of tangent line is exactly the instantaneous rate of change, which is f prime over A. So let me write two remarks here. Remark 1. for a line average rate of change well, what I mean by line, if function is an equation for line, something like this, rate of change on any interval, let me write C and D, is equal to rate of change at any point. I'm using at any point. Well, these are exactly for the line, these are the slope. You remember this, yes? Slope is you choose any 2-point endpoint, difference of endpoint divided by the x's, the difference of x's. This is exactly where this comes from. And somehow it's again trying to capture the notion of slope or changing at the point, and all of them, and you see that the central point here is that f prime of a. That was first remark. The second remark is that, remark 2 is that when you have a function, let's say this function a, same function, and you have average rate of change, average rate of change on the interval a b is basically, you see, remember this guy here is going to be f of b and this is f of a. The average rate of change of f on AB is exactly equal to slope of the line connecting two end points of the graph of f on AB. So this line here, you see, this line is the line connecting the endpoints of the graph on the interval AB, and the slope of that, because you see this point here up here is BF of B, and this point down here is AF of A, and the average rate of change is exactly y2 minus y1 over y2 x2 y1 x1. This is exactly y2 minus y1 over x2 minus x1. So this is average rate of change, but if you have a point A here and you're trying to find the instantaneous rate of change at x equal to a, basically you're trying to find a slope of not the line connecting any 2 points, just line which is tangent to the graph of the function at that point. So this is where so this is equal to slope, the slope of the tangent line to the graph of f at that point. So you see there are differences. This can be way different than the slope of this line, and that's what we have here. Okay, so the notions are there. Average, for average rate of change we have an interval. For the instantaneous rate of change we need a point, and differentiation will give us everything. So let's do some examples I have prepared. Let's see. Yeah. Our function f of x is x squared minus 3x plus 3. Find the average rate of change. Remember, always average rate of change comes with an interval. And that is equal to this is equal to f of endpoint minus f of the starting point of the interval over endpoint minus the starting point. Here means that we have to evaluate the function 4 squared minus 3, 4 plus 3 minus 1 squared minus 3 times 1 plus 3 over 4 minus 1, which is 3. 4 squared 16, 12, 3 minus 1 plus 3 minus 3. These cancel and we get what? We get, this is 4 plus 3, 7 minus 1 is 6 over 3, which is 2. And yeah, that's what we have. But how about the rate of change at a point? So this is, as I said, when you don't see just average rate of change, the word average, it means that this is instantaneous. That is what we have for the terminology convention we have here. So rate of change, for the rate of change, we have only one point at 2. This is f prime at 2. We have to find f prime. This is a polynomial, so we are trying to find derivative of x squared minus 3x plus 3. This is sums of derivatives, or well, differences of derivatives, doesn't matter here. The first one is derivative of x squared is 2x to the power 2 minus 1. Minus this 3 comes out because that's a constant multiple rule. Then derivative of x to the power 1 is just 1. Plus derivative of 3 is 0. So we have 2x minus 3. And we plug in 2, so it will be 2 times 2 minus 3. And that gives us 4 minus 3, which is 1. Instantaneous rate of change at 2 is 1, but average rate of change of the function on that interval 1, 4 is 2. Okay, nice. That was one example. Another example is, well, from this point on, basically what we have is that whenever you see rate of change or instantaneous rate of change, it's another word for find the derivative of the function. Yeah. Okay, so here we are trying to find basically instantaneous rate of change of this guy is equal to f prime at the given point 4. So we have to first find what is f prime of x. This is root x plus 2 over x minus 3 prime. This is quotient, yes, two functions divided. Now we have to find derivative of that. Derivative of the numerator times the denominator minus the numerator itself times the derivative of the denominator. And then x minus 3 squared, denominator squared. Okay. The denominator squared is there. So x plus root x plus 2. We have to find derivative of root x plus derivative of 2. Here, root x plus 2 times derivative of x minus derivative of 3. Derivative of root x, you can see root x as x to the power 1/2 and then use power rule. But if you remember, I said that try to remember this rule. Derivative of root x is 1 over 2 root x plus derivative of 2, this is a constant, it's 0. x minus 3 minus root x plus 2 times derivative of x is 1, derivative of 3 is 0. Now you plug in f prime at 4 is equal to 1 over 2 root 4. This 0 is nothing there. So 4 minus 3 minus root 4 plus 2 times 1 over 4 minus 3 squared. I don't know why this went down like that, but I can do a little bit better here. Okay. And this is equal to, this is 1 over 4, this is 1, this is root 4 is 2, so we have 1 over 4 minus, this is 2 plus 2 is 4 over 1 squared. So that will give us 1 minus 16 over 4, so it will be negative 15 over 4, 1. Negative 15 over 4 is what we have as the rate of change of this function at that point. Rate of change, we have two kinds, average, we need an interval for that, and instantaneous, we need a point. Instantaneous is an instantaneous rate of change, or simply rate of change is another word for find the derivative at that point.